We're now going to look at knowledge stores, and basically we can have text, CSVs, PDFs, etc. This one and this one here, I've basically taken this one here and this one here. I've taken a PDF, converted it outside of the app into a text file. This is the PubMed. It's all those 10 abstracts, something on Collinson, something's on general information, as CSVs. I had a few limitations with actually reading different types of files, but we can work around that. But I've got a good bit of information here and we can have a look at that. For Collinson, some different information. Some of the things have to be deduced. The massive article on the cancer, this will textbook Bible, a CSV, and we'll see how it deduces price from price. Like when I ask it for the price of carrots, it will know that price relates to this column. The PubMed, the 10 abstracts from those articles that we had, and some other information. So if we go to the actual file, what we've done here is basically, I'm just going to spit out the information. We load in, we make vector stores, etc. Then basically I have some sample questions here. For example, what is GTVP? A whole list here. But I then made, say, 10 questions based on RMS from the PubMed. I then made 7 questions from Collinson, made some general questions here. And if we run it all, which we'll do shortly as we see it, we'll see that it actually brings out the information and can actually deduce quite a few things. Because as it's doing that, one of the questions, as I said, was what's the price of a bunch of carrots? Well, it's reading a CSV file and deducing from the column of price, and here that will be the price. The same with Collinson. I'm going to ask different questions about who went where, what is Oxbridge, when do Colin and David meet for a call. And this is using fairly basic AI search, and they're far more advanced versions. But we can do all of that. And as I said, we have the PubMed articles, the abstracts that I put into one big file. So if we run that, it takes a little bit of time just to go through as I'm on a slow machine. As we're coming on down, we're loading the questions. The price of an electric car is 444. Well, that was one of the questions I asked, but it could see in parts that that's the price there. I've asked it to list some skeletal muscle questions on a particular article. I've then come through down here, and as you can see, it's printing out the answer to all these questions and answers that I've got on RMS. And also for Collinson, for example, it can deduce various things as well as extract. And this is what we're really doing, is that the question we ask or the phrase we're looking for isn't lexically in the text. It's through its meaning, its semantic meaning, it's hidden, and through vector space. So, for example, what is Oxbridge? Well, if we come into Collinson, for example, here, Craig went to Oxford University, read, is a combination of Oxford and Cambridge. Oxford is a combination of Oxford and Cambridge. We don't ask exactly what is Oxbridge. It can deduce that it means the same as basically what Oxbridge is. Oxbridge is the combination of, and I've asked a different question. I've asked, what is Oxbridge? So it found the meaning of the question rather than the literal. So with all of these things, we can see that we've got a very powerful knowledge base, and basically it's a matter of them building, as we see in the next video, what we're actually going to be using as our data store.